The purpose of this investigation is to determine the average global surface air temperature on the day of December 30th, 2011. We will do this by finding and recording the high temperature for this day. The independent variable will be the intersections of the navigation coordinate points where we will get our readings from. Specifically, those which are intersections of the 30 degrees each, such as the point 0 degrees latitude, 150 degrees east longitude, or 60 degrees north latitude, 30 degrees west longitude. The dependent variable will be the corresponding temperatures to each of these points. As for keeping everything constant, we will be recording everything in degrees Celsius, and we will be using coordinates rather than cities to get a more evenly spaced and widespread data. But here is where we run into some issues. We must assume that all the first-hand equipment used to record these temperatures are sufficiently accurate. Many places on Earth do not have very high-tech or precise equipment, which could mean that some of this equipment does not give accurate readings. In addition, we must assume that every data point will have temperature readings available. Some places in the middle of the ocean might not have recorded temperatures. In this case, data will be weighed accordingly to try to eliminate this difficulty and account for any lack of info. The method we'll be using to collect this data will be first to collect the high temperature readings from the various coordinate pairs individually, as in each person in our group collects some data, and we'll then combine it all onto a spreadsheet and weigh the data points as necessary. Then we will calculate the average temperature using this data and draw conclusions from those calculations. Here we have our recorded data. As you can see, there's a lot of variation in the temperatures of the data. As shown on the chart, the uncertainty of the coordinates is 5 degrees, plus or minus 5 degrees latitude or longitude, giving each data point a range of anywhere within 10 degree by 10 degree square on the map. This is determined through the analysis of the availability of the data points. Some points were a few degrees off from the identified or the intended coordinate, so we have this uncertainty to help fix that. The uncertainty of the temperatures is plus or minus 2 degrees Celsius, as shown in the graph. This uncertainty was determined through the analysis of the validity of the sources and the weighing of the data. Some of the data that we had to be weighed in order to account for a lack of information, and this uncertainty helps eliminate any errors there. The average of the data, which is shown over here, is about 13.92 degrees Celsius. This average was determined by taking the sum of all the data that we had collected and dividing by the number of data points. This average is actually the average global surface air temperature that we were looking for. As you can see, it is marked clearly on the graph by a large orange dot. As the graph is not in any way linear, no trend is apparent other than that the far southern parts of the planet and the far northern parts of the planet tend to be colder than the places closer to the equator. As shown by the data, the average global surface air temperature on December 30th, 2011 was about 14 degrees Celsius. It was earlier stated that some of the constant variables were not reasonably able to be kept fully constant during the investigation. This creates many errors, including one systematic error, the insufficiency of the equipment used by the original sources in the collection of the temperature data. These sources may not have had the sufficient equipment to collect accurate readings on the temperature. Also, it is not easy for one to know the validity of the information provided by the website sources that were used during this investigation, making that a systematic error as well. As for random errors, our documentation and processing of the data that we had collected could cause problems to arise. We cannot really comment on the validity of our data because one cannot generally find the average global temperatures for a single day to compare our data to. Most of the time it's in the form of the global temperature for a month or a year or something like that, not single days. Based on our procedure, our investigation went relatively smoothly. The procedure stated that we would weigh the data as necessary, and that is what really ended up having to happen. There may be much better ways of finding the average temperature than using navigation coordinates, but we did not have the time or resources to do so, especially in that we couldn't find sources that would actually provide these types of better methods. Weaknesses. One weakness was that it was difficult to find some of the data in the distant areas of the ocean, areas that weren't exactly charted, or there were no real cities around there, and that our resources were limited, in that we had a little bit of time, and there was no real set resource that we were supposed to use to gather this data. We had to get it all from separate sources and from separate people, basically, and combine it all. And as I just said, also we had limited time to do the investigation. The first two weaknesses were addressed in the analysis of the uncertainties of the data, so their significance to our resulting analysis is not very applicable. However, more time could have allowed for less uncertainties overall. When it comes to the precision of the data, the equipment used by the original sources is the only thing that we could think of that would in any way affect the precision of the data, especially in that precision involves having multiple trials, and this investigation did not involve using multiple trials or taking multiple trials of each of the variables. As for accuracy, we have no known value. As was stated before, there was no sources that gave a specific day, the average temperature on a specific day for the whole world, so we had no known value to compare our data to, making it not applicable. There are many improvements that we could have made on our investigation. One of the biggest ones was the time limit in which we were subjected to. This was a big issue because we didn't get a chance to actually meet together and work through and find the data points that we needed to, resulting in our process having to be that we collected data outside individually and then combined later from separate sources, which just created more uncertainties. And if we would have had that chance to actually sit down and find all the data and check it with separate sources but keep consistent with each other, the uncertainties would have most likely been reduced. Another improvement would be more data in general. As our procedure stated, we had collected data from the multiples of 30 degrees coordinate pairs on the map, and if we would have made a smaller margin, let's say, multiples of 5 degrees or multiples of 2 degrees even. That would provide more information and more room for uncertainties to be ironed out, basically. In an ideal situation, we would have to go to every coordinate on every place on the planet and record the temperature all on one day at the same time of day, relatively. But being that that is not humanly possible, there are always going to be uncertainties and errors in these types of investigations.